We'll now move on to item 10 in the agenda, the effect of climate change on Hurricane Ian. Michael Wehner from the Lawrence Berkeley National Laboratory is going to give a presentation. Next slide. So we'll discuss the implications and findings in a rapid analysis study conducted on the rainfall of Hurricane Ian during the time of impact on Florida. There'll also be discussion of the likelihood that other impacts of Hurricane Ian were also worsened by global warming. The connection to our CCMP is that this relates to fish, wildlife, and habitat restoration, Action 3.1, assist in assessing and promoting the economic, social, and environmental benefits of land protection and habitat restoration, including as a response to climate stressors. So with this, I would like to turn it over to Michael Wehner and Kevin Reed.
Thank you. I'm hoping you can hear me all right.
Yes, we can. Thank you.
All right, they're wonderful. Thanks for inviting me. I'd like to discuss some work that my colleague Kevin Reed, who's at Stony Brook University, and myself did on Hurricane Ian. Next slide, please. This is probably the most important slide. It says that what I talk about today are my opinions only and not that of the United States Department of Energy, the University of California, nor the Lawrence Berkeley National Laboratory. Thank you. Next slide. So here's the storm as it was impacting the west coast of Florida. You can see it's a large storm, and of course the damage was of epic proportions. Next slide, please. So the damages mainly came through two mechanisms. The first I like to call saltwater flooding, which is the storm surge and the coastal damage, which I think this picture is Fort Myers, which happened right away. As the storm was in that configuration that I showed in the previous picture, Fort Myers was getting hammered by as much as 15 feet or more of storm surge. The second happened a few days later as the water from the rain, so I call this freshwater flooding, percolated through the land system, the water system, and flooded homes and other areas. And here you can see some of the muddy water discharging into the Gulf from a satellite view. There probably is also wind damage as well, but I think these are the two largest and rather independent damage sources. Next slide, please. So storm surge comes about because of the wind. And how does climate change affect the wind? Well, we have both theory and modeling that tells us the winds in the strongest storms, like Ian, become stronger with a warmer world. And this is for two reasons. There's more available energy from the increased ocean temperatures, and there's more available energy from a moister atmosphere as well. And so wind damages would be greater and storm surge would be greater if this is happening. However, at this point in time, the way the climate scientists like to make these kind of statements is through something called formal detection and attribution, which is a series of steps, statistical analyses. And they have not yet revealed a significant change in the historical record. And the reason for this is it's really, this kind of work is a signal to noise exercise, and the variability from one season, much less one storm to the next, is very high. We do expect this signal to emerge, and I think there may be different ways of looking at it that we haven't quite got our hands around yet that might be able to confirm what we expect in theory through the observational record. Next slide, please. So how does climate change affect the rain? Well, this is a different story. Theory again tells us that the moisture in a saturated atmosphere, a fully saturated atmosphere, when the relative humidity is 100%, which it would be in a hurricane, increases at a rate of about 7% per degree centigrade increase in local air temperature, about 15% per degree Fahrenheit. This is known as the Clausius-Clapeyron relationship. This is an old thing. It was developed in the early 19th century to increase steam engine efficiency. So this is not rocket science, it's steam engine science. However, we've shown that hurricane rain actually increases at a rate greater than this 7% per degree relationship And this comes from a study of many previous storms. The first one that the community really dove into was Hurricane Harvey, which impacted the greater Houston area in Texas. I'll speak more about that particular storm. But also Kevin and I looked at Hurricane Florence, Hurricane Dorian, Maria, and Irma were looked at by Christina Patricola and myself, and many, many other storms. And for instance, this is one of the better pictures I have of Hurricane Maria. Could go back, please. Where our simulated precipitation of the storm looks like the panel on the left, and the amount of climate change that we've currently had, which is a little over 1 degree centigrade of global warming, has increased the precipitation as is indicated in the middle panel. And on the right panel is what we would expect at the end of the century under a business as usual climate emission scenario of greenhouse gases. And you can see that there's actually even a structural change in the pattern of precipitation where the biggest increase is in the center of the storm. The increase is the largest where it's raining the highest, and actually the outer ranges of the storm go down in the precipitation range, just indicating the storm is more compact in a future world. Next slide, please. So earlier in 2022, Kevin and I with Colin Zarzicki, published a paper on the effect of climate change on precipitation during the entire 2020 season. This is the first time we'd have done the whole season, but prior to that, we'd only looked at individual storms. And the way we do this is we do a hindcast of the actual storms. The hindcast is like a forecast, only it's after the fact. So it's a little bit better constrained. And we compared simulations of the actual storm to a counterfactual storm without climate change. So in a cooler world that might have been, how would this season have looked? And we concluded that for hurricane strength storms over the entire 2020 season, that extreme 3-hourly rates, so the short-term rate, increased by about 11% because of climate change, and the total storm rainfall increased by about 8% in any given location. And for the strongest storms, these numbers can be a little bit higher. Next slide, please. So what do we say about Hurricane Ian? Well, on September 29th, we used Twitter, which turns out to be a remarkably effective way of disseminating rapid information. We wrote the following. I'll read the quote, the tweet. Using the same attribution technique recently peer-reviewed in Nature Communications, preliminary analysis by Professor Kevin Reed and Michael Wehner shows more of the same for Ian. Human-induced climate change increased Ian's extreme rain rates by over 10%. Next slide, please. Well, how do we come up with this attribution statement so quickly? Well, Kevin just used the codes that we had developed from all those previous storms that we applied to 2020, and he reinitialized it with Hurricane Ian forecast data from National Weather Services. We went to bed, we had results in the morning. And here's two examples of the kinds of things we got out of that exercise. On the right is a simulation of the actual storm, or the storm under actual weather conditions and climate conditions. And you can see, it's a reasonable approximation of the path. It turns out this model is a climate model, but it actually works pretty well as a forecast model. And on the right, or left rather, you see this counterfactual storm, the storm that might have been had the climate not been interfered with by human activities. And you can see that there's less rain in it. But we want to get quantitative, so next slide, please. And our initial statement was deliberately conservative. Perhaps the most important words in it were over 10%. So this is sort of a lower bound on our estimate of the influence of climate change. And our current statement in a paper under review is that, very formally, that the 99th percentile, so the highest rain rates in the total, really 3-day accumulated precipitation over land in Florida, increased by almost 18%. That's our best estimate. We have the statisticians like myself like to speak in terms of quantify our uncertainty. I like to phrase that as a confidence interval, and that very broad confidence interval is about 15 to 21%. So this is a big number, and it's definitely exceeds the rate that the steam engine relationship from the 19th century, the Clausius-Clapeyron 7% per degree thing, given that there's about 0.8 degrees of centigrade of warming in the Gulf off the coast of Florida in September that's attributable to human consumption of fossil fuels, that works out to about 3 times that 19th century rate. So that's kind of a big deal. Next slide. So what about the real impact? Not just, rainfall is one thing, but it's the flood that we really care about. And we haven't done that for Hurricane Ian yet. I'm trying to explore some possibilities to do that. It involves other collaborators. But we've written a lot about Hurricane Harvey, and recently in a paper that's in preparation for Hurricane Ida, the remnants of the storm actually in the East Coast. For Hurricane Harvey, we've written a series of paper, and I like to call it end-to-end attribution. And so the story for end-to-end attribution in a phrase is that global warming caused about 1 degree centigrade in August off the coast of Texas. That degree of warming of the ocean led to about 20% more rain in that storm total, which led to about 14% increase in the area flooded, which led to an increase of about 32% more homes flooded. So it's kind of a big deal. A third of the homes being flooded really increased the damages. So climate change didn't cause this storm. I want this to be really clear. Causal inference of complex events is complicated. There are many factors, but climate change had an effect on the storm. Didn't cause the storm. It caused 32% more homes to be flooded. However, so that's an important distinction, and a lot of people get confused about these attribution statements and what we mean by what caused what. This should say Hurricane Ida. I'm sorry, that's a typo. 5.5 million people were flooded because of climate change. This is a heavily populated area. About 500,000 people were flooded because of climate change out of that 5.5 million. So the number of victims of that storm was increased by about 10%. Both of these analyses reveal profound socioeconomic disparities. The poor and the disadvantaged generally tend to be the most impacted. And that's true in extreme weather. And that's true in these two storms, and climate change exacerbated that disparity. And right now I'm searching for interested partners who can do the inland flooding, the freshwater flooding, to extend that work for Ian. Next slide, please. What about the storm surge? Well, I said before that we haven't identified that the signal that the human increase in wind has been detected and attributed, but that's because the way we've been looking at it in the past is through this Saffir-Simpson scale, the instantaneous wind speed that determines the category that's widely used to communicate the risk of hurricanes. And that's not a very good detection variable, it turns out, because it's very noisy because it's a point thing. Well, storm surge is integrated. It is a function of the winds over a large area and over time. And this finding that there's a rate greater than the 19th century scaling for hurricane rainfall means that the storm is more efficient at precipitating. This puzzled me for a long time, but I realize now that what it means is that the winds are indeed stronger on a large scale. It's just basically that it's a Category 4 storm, but it's a little bit stronger Category 4 storm in terms of the energy involved. And so we're exploring the possibility of using a storm surge model to quantify the climate change impact on Hurricane Ian's surge. And in a project led at the Pacific Northwest National Laboratory in Washington State, Mithun Deb produced this picture from his storm surge model, showing a fairly accurate depiction of the actual storm surge. And so we're trying to decide, how we would do the counterfactual storm in a cooler world, and then make that comparison. Next slide, please. That's it. And I'm happy to take questions.
Any questions from everybody in the room? Any questions from anybody online? Please unmute yourself.
Michael, I have one. This is Jennifer Hecker. You, I think, had mentioned this in a previous iteration of this presentation about the rapidity, how quickly the rain drops and how that can be affected, I believe, by temperature. Is there anything that you can elaborate on there? Because I think many of us did experience pretty extraordinary rainfall totals.
Well, our results show that the short-term, cloud bursts, or the really intense periods that are relatively short compared to the duration of the entire storm, increases at an even greater rate, and that probably is a large part of what's driving the overall storm total increase. And so, this is true not just of hurricanes, but we have recent work on the storms that impacted California, where I live, where the same kind of result has come through, is that the storm total precipitation increases at a certain rate, but the short-term periods can increase at a greater rate. And so in places where that's a factor, particularly in like urban areas where the wastewater management system can't handle that short-term volume of rain, this can be a problem. Hope that answered your question.
I have a quick question.
Sure.
Yeah.
Go ahead, Scott.
Scott Kerouac, Highlands County. When you talk about climate change and climate change being affected by humans and the use of fossil fuels and things like that, and being in Florida in the Sunshine State, and doing a little bit of research because we've had some agricultural producers that have seen a shift in their weather pattern since solar fields have been located close to their properties, and there's something called the heat island effect. Is there any ongoing research? I know that there's a couple of universities that are looking at this. Is this something that you've ever heard of, or something that is potentially being looked at?
I have not looked at that, at such a thing. But it is clear that there are local effects from land use change. And they generally tend to be local and not large scale. And so, if you change if you take an orchard, for instance, and you were to pave it over in asphalt, things would be warmer. Or if you just cut the trees down and there was sand underneath, it would probably, because that soil will be lighter. Locally there would be an effect of some local cooling. And so it's not outside the realm of possibility that by putting solar panels over some light colored land, because those are dark, that you would increase local temperatures. But I'm not aware of this being a large issue. I would caution that the climate is a very variable system, and it's variable both in time and in space. And as you get to smaller and smaller scales, the variability gets larger and larger. And so the data can fool you. You think you made a change and you see some change, and that change could go either way depending on which area you're in, because the natural variability is large. And so I would caution against drawing any conclusions about observed temperature records on a small spatial scale. One has to, I think, before having any confidence in a climate change statement, look at a lot of different places and over a long period of time. And that's hard to do at a local scale. For the storms, our confidence comes from the fact that we've looked at probably 30 or 40 different storms at this point, and the answers come out the same way each time. For Hurricane Harvey, for instance, there are 3 independent groups, one of whom I didn't even know at the time when it was done. And we all came up with attribution statements about precipitation that were within each other's confidence intervals. And so that was using independent data sets, independent methods. And the one group that I did know, we deliberately didn't talk to each other until after we published our results. Independence being a good way of validating each other.
One final question from.
Thank you, Mr. Chair. Ken Doherty, Charlotte County. I'm just curious as to whether or not you had any data and whether this relationship with temperature and rainfall held with Hurricane Michael that hit the Florida Panhandle a number of years ago.
I didn't do Hurricane Michael specifically, partly because I don't like the fact that they named it Michael. That kind of annoys me to no end. My wife's name is Camille, and that was a famous hurricane as well. But no, I haven't looked at that storm, but I'm pretty confident that because that was such an intense storm that that climate change increased the precipitation by a rate greater than the global warming alone would suggest, more than 7% per degree. But we have not done that particular storm. This is a rather, this leads into a question that actually is very important. Kevin and I are academics. We write papers. That's our job. And we wrote a paper recently where we argued that this kind of work really needs to be taken over by operational centers, by the federal government, and pay people to do this kind of thing, because we get these kind of questions all the time. Do you know how climate change affected this storm that impacted me? And it's a very small community. We can't do everything. And in fact, this storm, oddly enough, I thought the result was pretty interesting, but we are having difficulty getting this result published. And the reason being is because we've already published on this, and everybody comes back and said, well, this is kind of boring because you already told us this. And so that to me is another indication that this kind of attribution science really needs to be operationalized and turned over to the appropriate parts of the federal government.
One more question from Don McCormick.
Professor, California has been experiencing a phenomenon called atmospheric rivers in the past couple of weeks with the enormous rainfall. Are the mechanics of atmospheric rivers related in any way to the mechanics of a hurricane?
They're very different, and we're well aware of it. We got a lot of rain at our house. As it turns out, in a study that was joint with the San Francisco Public Utilities Commission, so these are people, the people that are concerned with the wastewater management, we found a very similar result, which I think is kind of coincidental because the mechanics of the storm were very different. But we also found that global warming increases precipitation in very extreme atmospheric rivers by a rate greater than this the 19th century scaling. And in fact, I actually made a statement based on a paper that Chris Patricola and I wrote in that study that climate change increased the precipitation in the first storm, which was the atmospheric river with a bomb cyclone, which is the one that affected the most, by 5%. And that number was low because, again, being conservative, and also the global warming off the coast of California has increased temperatures less than in the Gulf of Mexico. And so that the temperature increase is a little bit lower.
I appreciate your.
It's an interesting question because there's no reason to expect that different kinds of storms would respond the same way to global warming, and I don't think that they do. I think that this is a relatively new area. There's a lot of different kinds of storms that we haven't been able to analyze in this manner. Most interesting are the ones that produce tornadoes and hail in the Midwest that are called mesoscale convective systems. And that's something that I'm hoping with new computers, we can make progress on.
Thank you again for the presentation and response to the questions. Greatly appreciate the information that you shared.
Thank you.